Good morning. Welcome to GATE coaching class. I am Dr.T.AMITHA, Professor Computer Science of Engineering, S.A.E.C Engineering College. Today we are going to see the topic is data structures. Under data structures, we are going to see about a tree and binary tree. So what are the topics which you are going to see today is introduction to data structure, tree concept, binary search tree, AVL tree, and some of sample GATE questions. What is meant by the data structures? So all must know what is data structures. So this data structures, it is a way of organization and store data efficiency. It improves performance of programs and it helps the fast search and sorting of your computer programming. So there are two types of data structures are there. One is a linear data structures, another one is a non-linear data structures. So linear data structures: array, linked list, stack, and queue. So this is the linear structure. They have organized data. We can include and exclude the data. Non-linear data structure, we are having a diagram representations, that is a tree and graph. So today class we are going to see a graph. So what is meant by the graph? It is a hierarchical data structures, so which is containing nodes and edges. So example, binary tree. So what is meant by the binary tree? So binary tree, it is a collection of nodes and connected by the edge. The top node will call it as a root, and each node can have a child node. So we having a tree structure. So this is a sample tree structure for your binary tree. So first node we are going to say about a root, and we are going to say another, you can create a left side and right side child node you can create. The top, this is a root and this is a parent, and we can make subtree also, and left child node also you can make, and right child node also you can make. So each parent node have a two child nodes. One is a left side and right side. Again this child node can have a sub child nodes, that is H and K and L. So this tree structure, we can analyze the height of your tree. So height of the tree is, so the first is you having a level 0. All the height we are going to take with your level 0, level 1, level 2, level 3, level 4. So I am given a diagram representation. Here the height of this tree is a 4. So you can make how many heights you want, you can make it. Depends upon your root and parent and subtree. So root will be the top and the parent will be the next node, and each parent will have a child node. So the basic terminology of your tree: the root, the topmost node, we have seen already the diagram, parent and child node, and next we are having a leaf node. Leaf node means the last node. There is no children, nothing will be there. Next, each tree we can identify what is your height and what is your depth. So binary tree, the different type of trees are there. One, you having a binary tree and binary search tree. So BEST, and AVL tree, heap, and B tree. So today class we are going to see binary tree and AVL tree. So what does mean the binary tree? So binary tree means must have a two child node, that is left side one and right side. So each node has a at most two children, and you have a left and child node, and you have to express in your tree structure. So what is the tree structure we are having? This is a binary tree diagram. So you have a B, C, and D and E. So A is a root node, and P is a parent, and D and E is a child node, and C. So every node should have. So the C we can call it as a leaf node because there is no subtrees are there. So this tree we are going to classify into three different ways. One is the in order, pre-order, post-order. So why you need a travels a tree? It is every node has to visit whether it is in correct order or not. So we are going to see in order, pre-order, post-order. So in order is you having a L, N, R. I have written as L, N, R. L is for left side and N is node, R is right. So each and every node how we are have to present, we are going to see with the examples. So the same diagram I have written about your tree structure, that is first in order travels. We are going to see about this is a root node, this is a left side, and this is a right node. So in order is first you have to visit only the left and node and right. So what is in a left side? Here is a left side. So I have written as 4. Next I have to go for your 2. That is node, and I have 5. Next you are having a node and right side. So this is a in order tree traverses. So next you are having a pre-order. So pre-order is I have written as N, L, R. N is node, L is left side and right side. So the same diagram how we have to represent for your pre-order traverses order. So first I have to written as a node. Next left side values. So 1, 2, 4, 5 and 3. Same one I have written for your post order. So post order is we have to write for left, right and node. So we are having a left side value is 4 and you have to write for right side 5. Next this is a root 2, 3 right side. Then next you have to go for your 1. So this last one is a level order of your traverses. So we have to have some directions, that is you have to follow first is a root, left side and right side. So 1, 2, 3, 4, 5. So left and right, and you have to write it. This is a level of order. It is a normal traverses. So mainly we are concentrating only the 3 traverses. So binary traverses. So that previously I have explained. Same explain. I have given a diagram 1, 2, 3, 4, 5, 6, 7. So first which you are going to see the in order. So in order is we have seen as a left node and right we have to do. So we are taken as a left and a root node is 2 and 5. So I have written here as 4, 2, 5. Next one is after left is completed we are going for a main node and right value. So right value we have to take this one other subtree. So left, root and you have to take the right values. So 4, 2, 5, 1, 6, 3, 7. This is for first in order travels. Next the same diagram I am giving for a pre-order traverses. So how to represent about your pre-order traverses. So pre-order traverses we have to see the root node, then you have to see the lefts and you have to go for a right. So I am given as a root 1 and 2, 4, 5, 3, 6, 7. So that is a diagram I am given here. Next I am given as a post order. Post order we have to see on the left and you have to see about your right and then you have to go for your root. So that is order I have maintained 4, 5, 2, 6, 7 and 3, 1. So this is sample representation for your traverses techniques. So binary search tree BST. So this is the next one. So small changes there from your binary tree and BST. So BST we should have a root will be there and left side tree values must be the less value of root and right side the value may be the greater value of your root value. So there is a one condition we have to see. So left side subtree less than of your root and right subtree is a greater than of your root. And what is the efficiency of this? Logarithmic of order of n is the average value we have to find out. So I am just given as which is correct BST and which is not BST. That is a binary search tree. So I am given as a correct BST is a 831. So that is a root node. The left values are available in your less value and right side value is greater than of your root. So I have given as correct value. So same you can have only the root also should be possible, that is a leaf node, and only you can have a left value also you can have it. So this is the correct BST value. This is which is not BST. So duplication should not be there. Same value, the left side value I have given as a duplication value. This should not be there. And we should not have your less value of right side. That is also parent node value is larger than the right subtree. Same thing, parent node value is smaller than this 9 value. So this is not a BST tree. So you can do the insertion also. So you have to search from the root node to left side, right side. So this example I have written as a tree. I want to insert 40 values. So the initial value is here 100, 20, 500, 10 and 30. So I have to insert 40. Where I have to insert? So first I have to check the value of 100. This is a less value of 40 is less than 100. So first I have to check with the left side. It must be a left side. Next I have to check with your 20. 20 value is less the value of 40. So it must be a greater than value. So you should come in the right side. So I have given as a value is 100, 20, 100, and this instead of you are having a 30, after that the greater value we have to insert. Next you want to search. I want to search some elements in that. So same, first you have to start with the root. So I have given an example, given a root of binary search tree and the value of key. So any values which they can give. So example, they are given 6 or 2. So first you have to compare with your root. So root is less than min, you have to search only for the left side. If it is greater than value, then you have to go for your right side value. So next, deletion. So whether it is possible to deletion? Yes, you can do a deletion your binary search tree. So deletion node, I want to delete a 20. So first I have to identify where it is a 20 is there. So 20 I have to compare with the 50, it is less value. It must be the left side. So I have to go for the left. Next I have to search for the 30. Next I have to go for your 20 value. So it is there means you can delete. So I have written in a dotted line. Next I am given as one exercise. So I want to insert a value with 6. Inserting a value with 6 in this binary search tree. So where I can insert. So first I have to see whether 6 is left side or right side. So I have given a root. So here I am given a root 6 must be the less value. So it must be there in your part of left side. So after left I have to check 6. So again it is less than value. You should come here. So after 3, it is a greater value, you have to give in your right side value. So next, I am given a small example. So input is array. So I am given a value 19, 23, 25, 30 and 45. So I have to give whether the array is sorted or not, descending order. So which is the in order or binary search tree. So which order you have to identify. So in order only, it is a perfect order or sorting order, even BST. So it is a true. Next I am given it is in order or not, they are asking. So it is not in order because it is not a sorting order. So as the array is not sorted, then that is not a in order. So I am given 19, 23, 30, 25 and 45. So some values are not sorting. So I am given as in your value is in not in order, the statement is false. So I am given as a BST for a pre-order. I am given a input value 10, 5, 1, 7, 40 and 50. I want to do the pre-order. So pre-order value is first value you have to take. Next, what is the value is there in the 5. So less than value means you have to give in the left side. Right side value you have to give the greater value. So 10, less value 5. Next second value is 5 is less. So 5. Next one value is less than value. After that 7. 7 is greater than of 5. So I am given as a right side value. Same thing I am given as a 10. For next value is 40. Where have to do? It is a root 10. Then we have to, it is a greater value 40 and 50. So construct the BST from your given level pre-order. So in input order I am given 7, 14, 7, 4, 12, 3, 6 etc. So first I have to take the value as 4. Next element I have to search, that is for left side or right side. It is a less value, it must be a level of your 4. Next it is a 12, it is a greater value of root value, so I have given as a 12. Next 3 value, it is less value, so less value of 4, then what I should do? We have to draw in a 6. So like this I have to draw the values and I have to construct a tree structure. So next part is AVL tree. What does mean by the AVL tree? So AVL tree is same part which having a binary search tree, but here having a balance factor. The value or root must be balance should be there. That is AVL tree defined as a self-balancing binary search tree where the difference between the height between the left side node and right side node must be equal. So balance factor left subtree minus right subtree height. For a balanced tree, for every node it must be a greater than 1 or less than minus 1. That is your balance factor. So I am given an example for your AVL tree. So AVL tree I am given as, this is a correct AVL tree, 0, minus 1, plus 1 has to come. If the order is coming as a 2, that is not your AVL tree. Next, whether you can do for insertion. Yes, binary search tree also we did a insertion, deletions and removing values. Here also we can do the insertion, but in the different part. We having a insertion, deletions, everything. So we are going to use a part of your rotations. So this AVL tree, we are going to have a concept of, we can rotate sub trees of your tree structures. So we are having a rotating a subtree, we having a 4 part is there, that is single rotation also is there, and double time rotation also we can make it. So single time means right side or left side. So we have to rotate, and the AVL tree structure, the size of the height tree structure should not be vary. The equal height should be there. And double time also you can do, left you can do, or left and right also you can do it, and right also you can do it. So all the combination of left and right, it is possible to do the rotation of AVL tree. So first example I am given as a left rotations. So I am given as a value as ABC. So it is coming in the order, that is 0, 1, 2. So I want this unbalanced tree, I want to make a left rotation, that is a B value. I am rotating this A, so the value will come as a B. So B come the root and A will be the sub part, is a balanced one. Next I am having a right rotation, same diagrams, I am going to shift to a B value. So there it is coming BAC, here it will come BCA, there is a balanced tree. Next I am given as a rotating the subtree in AVL tree, that is a left and a right. So first time you have to do the left, and next time you have to do for your right values. So you have to do for CAB, I am given first time left and next time right you have to do. I have given a arrow diagram, the A to B, again this B has to change it, that's what I am given here. So A, B, C, then the value will be changing like this. So next we are having a right and left rotations. So we are having a 2, 1, 0. So that is AC, that is order is 2, that is unbalanced. So first you have to write that diagram. Before the diagram, it is a left and right, is a right and left you have to do. The order will come like this. So next I am giving a sample questions, how to solve it. This is a usual questions from your binary tree and AVL tree, or it is a binary search tree. So first question, suppose the value, I have given some values, are insert in the order into the initial empty binary search tree. Let T will be the resulting binary search. The number of edges, how many edges you can make with your examples. So I am just given an example as 10, minus 4, 15, 30, 20, 5, 60 and 90. What is the first one? The first one is a root node. I have made as a 10. So what is the next value? It is a minus 4. That is a less value of your 10 value, that is a root value. It must be constructed in the left side, minus 4. Next I have to take for a 15. So 15 is greater than of your 10 values. I have to take the right side, that is a 15 value. Next, what is the third value? It is 30, is again is a greater than value of 15. So you have to take the 30 value. Next is a 20. 20 is a less value of 30 and greater value of 15. So this 30 is a, we are having a top node, so left side you have to do. 60, next value is 60 is the greater, and 5 value is there. 5 is less than of your 10, so it must be a less value. So I have written here. So I have constructed tree structure. The question is asking number of edges needed for connecting 19. So 19, where is 19? 19 is here. So how many connections are there? 1, 2, 3 and 4. So we have to represent 4. Number of edges is needed 4. Next question is, consider the label sequence obtaining by the following pair of traverses. So what are the pairs this is possible? In order, pre-order, post-order, and order of traverses we have seen. So in that 4, which combination is the best one? So they are given as a 4, pre-order and post-order, in order, post-order, pre-order, in order, order level, and you having a post-order. So we have to select which one is the correct answer. So I am just given as a 3 options are given. Only A1 or B2, B3. So which order we have to, any order we can have it. So in order, post order and pre-order must be there. So if it is level of order is not there also, no issues. So they are given as a B2, there is a value is 2 and 3. Next question is, this is a 2004, they asked the question, with the following number of numbers are insert, same you have to draw the tree structure, and what is the height of your tree. So they are given as a value is 2, 3, 4, 6. So what is your answer? We have to check it. How answer is B. So what is how you have to construct the binary tree? So same value, root node, and you have to take the left as a less value and greater than values, and what is the height we have to check. So I have constructed 10, 1, 15, 3, 12, 16 is there. So order is you are having a 3. So 1, 2, 3. So the height of your order, it is 3 value. Next question is whether the binary tree number of nodes with 2 children are there, then what will be the answer? So that is leaves minus 1. So you having a number of nodes is 2 and binary tree. So full binary tree means they are having a formula 2 children means leaves minus 1, that is a formula. So you have to represent A is the correct answer. Next, what is the height of balanced binary tree with 100 nodes? I have given 100 nodes. So balanced tree is AVL tree. So we have to identify the logarithmic of 200. It is approximately 6.6. So here the nearest number is 7. So we have to write the value as 7. Next we have to see what is the sequence of your statement. This is also recently they asked. So they are given a 2 statement. One is a procedure call, that is a pre-order travels activation or or post order. What is the sequence you can have? Pre-order sequence or post order activations. So they are given as S1, S2 both are true. Like S1 true, S2 false, S2 false, S2 1 true. So both are false. The statement both order should be activate for your binary tree. So the answer is S1, S2 should be true. Next I am given as a BST insertion. I have to give insertion in order, and what will be the answer should come for in order. So in order I have to take a 10, 20. So it's a greater value I have to given as in a right side according to your in order post you have to do. So you have to take a in order travels of BST started. So the answer will be the in order, always the sorting order should come 5, 6, 10, 15, 20. So you have to draw the tree for first 10 and right side of 20 and left side of 5, and you have to do for 6. Again you have to do for right side of 15. Then the in order we know that left side node and right side value you have to take. So left side will come is a sorting order of less value, and root node will be the same value, and right side will be the highest value. So you have to take the left node and right value, mean definitely the sorting order will come in a in order level. So that is a question. Next, in binary tree you having full tree is how to identify the height. You have the formula of 2 power h plus 1 minus node. How many number of nodes are there? Heights are there, minus 1 plus 1, and you have to do for a minus. So the explanation complete binary formula was the first answer. Next, AVL tree rotations. So it is a singular, double or only single or only double I have asked. So already we have seen AVL tree, it is for your double. So LL or a single, LR, RL is a double. So A is a single or single, or it is a double. Next I am given as a which travels of BST give the element sorting order. So last 7th question I have given as in order always be the sorting order. And last one is AVL tree, balance tree. What is the formula for your balance tree? It is a negative value 0 and 1. So thank you. We'll meet in the next video.